So let's continue. Again, instead of using the given equation or working equation for permutation, you can also use fundamental counting principle. Okay? For fundamental counting principle, consider your R. So according to the whole problem, we will going to draw first, second, and third. So you have three positions there, 1, 2, and 3. Now next, out of the 120 names, say one of the names in 120 names is already drawn as first prize. So one of the 120 is already here. That is 120. Now next, since the one of the 120 names is already taken, your choices on the second prize will be lessened by 1. So instead of 120 here, you will have 119. Okay, that is 120 names minus 1 name for the first prize. Now, for the third prize, say one of the 190 names is already in the second prize. And then you will left with 118. And then proceed with fundamental counting principle 120 times 119 times 118. That is equal to, let me see, sorry for that. 120 times 119 times 118, that is equal to, okay, 1,685,040. Okay? Again, if you do not want to use the formula, you can always proceed with fundamental counting principle. Let's have another example. So in how many ways can a basketball team of 5 players be chosen from 8 players? Again, identify your given. N is 8 players. And R is 5. Next question. What will be your working equation? Okay, analyze the problem. Is the problem involves permutation, or the problem involves combination? What do you think? Again, is the problem for number 2 is a permutation problem or a combination problem? Comment down your answer. Let me see your responses. Okay. Yes, will you open your mic, Lorraine? Why combination, Lorraine? Lorraine?
Ma'am, because of the word chosen.
Okay, very good. Because of the keyword chosen. Okay, we have keyword here. Therefore, we will be using NCR, or the combination of n things taken r at a time, is equal to n factorial over r factorial, quantity n minus r, quantity factorial. Okay, thank you for your responses. Now, next, after that, just simply substitute. N is 8, r is 5. So you will have the combination of 8 things taken 5 at a time is equal to 8 factorial over 5 factorial, quantity 8 minus 5, quantity factorial. Now, as for PEMDAS, you have to evaluate this first. 8 minus 5 is 3. And then times factorial, that is 3 factorial. Okay? Now, next, you have to expand 8 factorial in such a way that you will be canceling out 5 factorial in the denominator. So when you expand 8 factorial, that is 8 times 7 times 6 times 5 factorial. You will end with 5 factorial because your goal is to reduce your whole whole expression. Okay? So over 5 factorial times 3 factorial. Okay? And then 3 factorial, you have to evaluate 3 factorial. That is 3 times 2 times 1. So you have 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1. Then after that, you have to simplify the expression by canceling out the same number or same expression. Say 5 factorial divided by 5 factorial is 1, so cancel out. And as you can see, 3 times 2, that is 6. So cancel out 6. And then you will have 8 times 7. And 8 times 7 is equal to, yes, 56. So the combination of 8 players taken 5 at a time is 56. And then do not forget your conclusion. Therefore, there are 56 ways in choosing 5 basketball players from 8 players. Now, what if you do not want to use that formula? You can always proceed with your next option. in which we will be using the combination of n things taken r at a time is equal to the permutation of n things taken r at a time over r factorial. Okay, and with that substitute, so we have the combination of 8 players taken 5 at a time is equal to the permutation of 8 players taken 5 at a time over r is 5, so 5 factorial. Now next, fundamental counting principle, insert, you have 5 positions. So 8 times 7 times 6 times 5 and times 4. And then 5 factorial expand, that is equal to 5 times 4 times 3 times 2 times 1. And then proceed with simplifying the whole expression. 5 and 5 cancel out. 4 and 4 cancel out. 3 times 2 is 6 cancel out. So you will have 8 times 7. And 8 times 7, that is 56. So the combination of 8 players taken 5 at a time is 56. Okay? Now next,